Hello again, class. So this is now the third part of linear DE. We will answer example 5 and example 6. Number 5, we have the quantity of x to the power of 5 plus 3y dx minus x dy equal to 0 when x is equal to 1 and y equal to 2. Our dy has last term, so we will follow the standard form of linear DE, linear in y. We follow the standard form y prime plus p of x y equals q of x. So, copy first the equation. So, x to the power of 5 plus 3y dx minus x dy equal to 0. We want to have y prime. So, to do that, we will divide both sides by dx, right? So, dy over dx is y prime. And make sure the y prime is positive and no variable or terms or coefficient next to the y prime. So we have to eliminate also negative x. So divide both sides by negative x. So if we multiply negative x dy to 1 over negative x dx, negative x is cancelled out. The remaining is dy over dx. If we multiply this expression x to the power of 5 plus 3y dx by 1 over negative x dx, dx is cancelled out and positive divide negative is negative. Then we copy x to the power of 5 plus 3y all over x. Positive divide negative is negative. This is 1. And copy x to the power of 5 plus 3y over x equal to 0. So, copy dy over dx. Then, our numerator has two terms and one single term in the denominator. By using the distributive property of division, this can be separated into x to the power of 5 over x plus 3y over x equal to 0. So, dy over dx is negative. X to the power of 5 over x is x to the power of 4 plus separate the variable x and y. So, 3 over x times y. And then distribute the negative. Copy dy over dx. Then distribute the negative. So, negative times x to the power of 4 is negative x to the power of 4. Negative times 3 over xy is negative 3 over xy equal to 0. Since we are following the linear in y, we should transpose negative x4 to the right side, right? Because it has no function y. So, dy over dx minus 3 over xy equals, if we transpose this one, it becomes positive x to the power of 4. So, we have now our p of x, which is negative 3 over x, and q of x is x to the power of 4. Next step is to find the if. If for linear in y is e to the integral of p of x dx. e to the integral of p of x. Our p of x is negative 3 over x. Negative 3 over x dx. The integral for negative 3 over x dx is negative 3 ln x. Then, using the properties of logarithms, negative 3 becomes the power of x. So, e to the ln x to the negative 3. E and ln cancelled out, so we have x to the negative 3 for the integrating factor. Third step is to use the formula. This one is linear in y, so the formula is y times if equals e equals integral of if times q of x dx. Y times if is x to the negative 3 equals x to the negative 3 times q of x is x to the power of 4 dx. Since we have a power that is negative, we will reciprocate the base x. So it becomes y over x cubed. X to the negative 3 times x to the power of 4 is equal to x dx. Integral of x dx is x squared over 2 plus c. Since this one is looking for the particular solution, we will substitute the values of x and y. X is equal to 1 and y is equal to 2. So y is 2, x is 1, 1 squared over 2 plus c. 2 over 1 is 2 equals 1 half plus c. Then c is equal to 2 minus 1 half. 2 minus 1 half is 3 halves. So c is equal to 3 halves. Then we will substitute this to this equation. So y over x cubed equals x squared over 2 plus c is now 3 over 2. Then, to eliminate the denominator 2 and x cubed, we multiply both sides by 2x cubed. If we multiply y over x cubed to 2x cubed, the result is 2y. If we multiply x squared over 2 by 2x cubed, 2 is eliminated. So the result is x to the power of 5. Plus, if we multiply 3 over 2 by 2x cubed, the result is 3x cubed. Okay? So this is now our particular solution. Last example. Number 6, dy over dx equals sine 2x plus y tan x when y is equal to 0 and x equal to 5 over 2. This one is already arranged, so we will follow the standard form of linear DE, linear in y. So the standard form of linear DE, linear in y is y prime plus p of x, y equals q of x. So we have to separate the y function and the y prime on the left side and the function x on the right side. So we have to transpose y tan x, right? So copy dy over dx, then transpose y tan x to the left side. It becomes negative y tangent x. Then just copy sine 2x. So this is now our first step. Our p of x is equal to negative tangent x. Our q of x is sine 2x. Second step is to find the IF. The IF is e to the integral of p of x dx. So e to the integral of negative tangent x dx. There are two answers for the integral of tangent x dx. One is negative ln cosine x and the other one is positive ln secant x. We will choose the answer that will make the solution positive. So e to the negative times negative ln cosine x. We choose this one so that the answer is positive. So negative times negative is positive. So e to the ln cosine x. E to the ln cancel out. So we have cosine x for IF. Third step is to use the formula. For linear in y, the formula is y times IF equals integral of IF times q of x dx. So y, the IF is cosine x. So y cosine x equals integral of cosine x times sine 2x dx. What is sine 2x? Sine 2x is equivalent to 2 sine x cos x. So this is now 2 sine x cosine x dx. So we put the constant outside the integrand. then cosine x times cosine x, cosine squared x, then sine x dx. To integrate this one, we will use the u substitution. So, we'll let cosine x as our u. Then we derive, derivative of u is du, derivative of cosine x is negative sine x dx. But, there is no negative here, so we will multiply both sides by negative 1. So, this becomes negative du and positive sine x dx. Substitute. So, 2 cosine x is now u squared. Sine x dx is negative du. So, negative integral of u squared du. So, copy negative 2. Then, integral of u squared du is u cubed over 3. But our u is equivalent to cosine. So, cosine cube x over 3 plus c. The left side is y cosine x. Y cosine x. But the values for x and y is 0 and x is pi over 2. Y is 0, cosine x is pi over 2. Equals negative 2 over 3 cosine of pi over 2 raised to the power of 3 plus c. 0 times cosine pi over 2 is 0. Cosine pi over 2 is 0. 0 times negative 2 over 3 is 0. So, plus c. So, c is equal to 0. So, this now, c now is 0. So, y cosine x equals negative 2/3 cosine cube x plus 0. So, we don't need to write plus 0. Both sides has cosine. We can divide both sides by cosine x. So, y equals negative 2/3 cosine squared x. So, our answer is y equals negative 2/3 cosine squared x. So, this is the particular solution. So, we are done with linear DE.